Okay, so find out how many possible minimum number of zeros for this function, which is continuous function on this interval based on the value of the function given in this table. First of all, to understand the intermediate value theorem, I'm going to use these two graphs of two functions, f of x and g of x. And the difference between these two functions is, the one is always positive, it's above the x-axis, and another function is sometime positive, sometime negative, and again positive. So it's changing, it's going from positive to negative and negative to positive. While doing that, this graph, because it's a continuous, means because of its continuity nature, it should intersect with the x-axis. And whenever a graph intersects with the x-axis, it gives you 0. So this is the 0. At 3, the value of the function is 0. That's why, this is 3 and 5 are the zeros of this blue curve. So that's the intermediate value theorem. If the value of the function is changing from positive to negative or negative to positive, at that point, at that on that interval, you are going to get at least one zero. By looking this problem, as you can see, the value of the function is always positive. There is no change. So so the answer, the minimum number of zero might be 0. So there is no zero actually, like the this graph, the red graph here. So that comes from the intermediate value theorem. So if there is no change of the function from positive to negative or negative to positive, the minimum number of zero is 0. There is no zero actually. If, let's say, if you are solving the very similar kind of question, but there is a change from, let's say, from 0 to 1, if the one value is positive and another value is negative, then the minimum number of 0 is at least 1, because you can see that one change. So if you see changes from positive to negative or negative to positive, that one change at least should give you 1 0. That's how you count minimum number of 0. Okay, hopefully you understood that thing. Otherwise, just let me know.